Hello, class. Today's Edpuzzle lesson is on our continued topic of projectile motion, and more specifically, horizontal launch. That's correct. In projectile motion, the horizontal acceleration is always 0 meters per second squared. A projectile has no horizontal force after it's airborne. Now let's get into the problem. A horizontal rifle is fired at a bullet. The muzzle speed of the bullet is 654 meters. The gun is pointed directly at the center of the bullseye, but the bullet strikes the target at 0.028 meters below the center. What is the horizontal distance between the end of the rifle and the bullseye? So, first we sketch what it looks like. So, this is your coordinate system, y being your vertical motion and x being your horizontal motion. Now, we list out everything we know. In our x column, we know everything except two variables, our final horizontal distance and our time. In our y side, we only have one missing variable, the time, which means that we have to start in our vertical y side and solve for the time, and then bring it over to our x side and solve for the final distance. So, in order to solve for time using our vertical information, we're going to use equation 4. So you'll notice that our initial velocity equals 0 and our initial distance equals 0. So that means our equation is now going to be our final distance equals 1/2 of our acceleration times t squared, which comes down to t equals the square root of 2 times our final distance divided by our acceleration, and that should get you to t equals 0.0756 seconds. So now, bring that over to your x side and solve for your final distance using the same equation. So if you notice again, our acceleration in the x side is 0 and our initial distance is 0, so that makes it only our horizontal distance equals our initial velocity times our time. And once you do that math, your horizontal distance should be 49.483 meters.